Hello, welcome to Fast Unlimited Side Slope Edits in Civil 3D, presented by Eric Arneson. A little bit about Mr. Arneson. He's a professional engineer and he is part of the Wisconsin Department of Transportation Methods Development Team, or MDU, that provides support, technical expertise, and future direction for highway engineering tools. He has 27 years of experience with WisDOT in highway design, construction, GIS, and supporting engineering software. He has 12 years of experience with Civil 3D and is the team lead on training and communication. My name is Paul Kirkendall, and I'll be assisting with Q&A moderation and have just a couple housekeeping notes before we get started. First, a big shout out to all of our sponsors for helping make this virtual workshop happen. Thank you, thank you. An evaluation link will be provided at the end of the session, as well as a larger email at the end of the day. Please complete it to help us improve our event. Evaluation completion is also necessary to qualify for those PDHs. Now let's start today's session.
Hi everyone, my name is Eric Arneson and this is my session on fast, unlimited side slope edits in Civil 3D. I've been at WisDOT for 27 years doing roadway design and construction and a lot of different ways for figuring out technology and getting it to do more work for us. I'm the person responsible for the Civil 3D knowledge base, the C3DKB, and I also happen to be the lead on training and communication for Civil 3D at WisDOT. Today's content is going to contain a lot of customizations. I'm going to walk through what functionality there is in Civil 3D and the reasons why we decided to customize this particular area of work. Everything that I'm showing you is freely available to download to everyone. Use if you want, and replicate if you want to too. One of the things that I do want to mention to you, I know a lot of organizations get into I can't use other people's stuff and whatever, and I get it, but there's no layer information there or anything like that in the sub-assemblies that we're talking about. All the sub-assemblies in Civil 3D run off of codes for points, links, and shapes. And all of the codes that we have are the same as what Autodesk uses or gives users the ability to edit in their own code. So no reason not to at least check it out. And hopefully I give you enough reasons to do that today. So in my experience with doing roadway projects, the vast amount of editing editing cross sections is in the side slopes. Typically there's a proposed roadway. It could be whatever it is. The majority of the cross section edits are in the side slope. So what I'm talking about is this area right in here. This just happens to be a nice little 2-lane rural, but the edits and the work in getting final cross sections all hinges between the subgrade shoulder point and what we call the slope intercept or the daylight point. The customizations I'm going to show you make doing those edits extremely fast and highly scalable. I think what I'm about to show you is the most important part of customization that we've added to our Civil 3D interface. If you're doing WisDOT projects, either in-house or one of our consultants, you need to be using these tools. If you are using Civil 3D somewhere else, I want you to see how fast and easy editing these slopes can be in Civil 3D with the right customizations. So we're talking about cross sections. Let's boil it down to the basics here. So at the fundamental level, cross sections are a proposed roadway, existing ground, and the connection in between them. This connection in between them is critical. There is no set of cross sections where the proposed roadway is floating up in the air. You've got to touch down to existing ground. I'm going to be calling these the daylight slopes. And because that's how Civil 3D talks about daylighting, but I'm going to be talking about it a little bit differently. So daylighting to me means getting from this subgrade shoulder point to the slope intercept. I don't care if it takes 1 slope, 2 slopes, 4 slopes, whatever it takes. Between there and there, I'm calling daylighting because that is the area that we are talking about, and it can change wildly. And it can also change without any regard to what your proposed roadway is. You know, it doesn't matter if this is 2-lane, 4-lane, 6-lane, whatever. That has no impact on whether or not this is a ditch, whether it's a side slope, whether there's a berm. All that information is the relationship between the proposed roadway and the existing ground. And that's why this part is so critical, because every single project that has cross sections, whatever its scope is, has to get from the proposed roadway to the existing ground. Otherwise, we wouldn't have cross sections. So every single roadway project that we have that has cross sections has to deal with daylighting. So how does Civil 3D out of the box control daylighting? Well, in Civil 3D, cross sections and surfaces are created by applying an assembly, which is in a group of sub-assemblies of logic that creates points, links, and shapes over a station range, which is called a region in a corridor. So you've got a width and you apply it down a length. That's your corridor region for an assembly. Now, changing the slope of a subassembly link can be completed by changing the link parameters. So the variables that control subassemblies' geometry are called parameters. Civil 3D is most efficient and effective, really, in changing these parameter values when targeting an object to control those values. Okay, so targeting is definitely the way that Civil 3D wants to manage parameters. Out of the box, Civil 3D can target 3 different things. They can target horizontal targets, vertical targets, and surface targets. And I throw in absolute for the horizontal and vertical targets because they are in absolute coordinates, okay? So the vertical targets, you can't target like a depth. It's not a 10-foot deep ditch. It's a ditch with an elevation of 973.64 or whatever. So that is what Civil 3D out of the box can target. They cannot target a slope. They cannot target width or depth. So relative dimensions, okay? You can't target out of the box, make this ditch 8 feet wide. It doesn't exist. So how can you control these daylight slopes in Civil 3D out of the box? Well, like I said, targeting is definitely the way you want to do it. Unfortunately, there isn't out-of-the-box functionality for targeting slopes, widths, or depths out of the box. You can, a very common place that people first go to are either parameter overrides or their graphical cousin, grip edits in a corridor. One of the pros of that is it's really easy to understand. People say, I want to change that 3-to-1 to a 4-to-1. They type it in and it works. Great. That's fine. However, it's super deep in the interface and it's really hard to figure out which ones have parameter overrides and which haven't. And in our experience, this solution doesn't scale well. You can get away with a handful, maybe half a dozen of these parameter overrides. You start getting into a ton of parameter overrides and your corridor files will bloat and slow way down on you. And I've seen some corridors where, half of the sections have edits on them. If you do that through parameter overrides or grip edits, the file sizes explode and you're getting into minutes of processing time. You do not want to do that. The other thing is that these overrides do not scale to 1 to 2 to 3 to 4 links. You can't manage multiple links with that. Running multiple assemblies. It works, but you can run into a ton of assemblies just to get different values and different link configurations out on your side slopes. And it doesn't deal with transitions between values. There's no, if you want to go from a 3 to 4 slope, you can have an assembly with a 4 to 1, you can have an assembly with a 3 to 1, and you need to let the corridor figure itself out in between those two. If you do any sample drops in between, all of a sudden you've got to start, figuring out the linear interpolation of it. It's a lot of work. There are conditional subassemblies. Those are, I kind of look at that as a kind of a power add-on for multiple assemblies. You can add some logic into assemblies and get less assemblies, but you end up with these conditional horizontal subs to drive your logic. You start building, what I see people do is they start building out these, we call it player piano. You've got these horizontal targets that all they're doing is managing your corridor for you. And you start getting into this place where you've got, branches and branches of logic, and it just gets a little crazy. And, even if somebody figures out, you cannot have somebody else come in and, figure out what's going on. It's just, somebody builds it and nobody else touches it. So it's there. It's not an awesome solution in my book. So what can you do if you open up the world of getting some customizations going? Well, let's talk about the problems, and then I'm going to give you what we have developed for solutions for these problems. So variable number of daylight slopes. I'm gonna kind of peel behind the curtain here. I'm not going to go into that one. I want some pictures. Sorry for the slowdown here, but let's expand. The problem that I'm talking about when I say multiple links is going from, say you've got one link to, okay, now we've got a recoverable slope and a non-recoverable slope in our fill section. Okay, so one link to two links. Okay, now we've got a ditch section. So now we've got 3 links, and it's got to go down first, and then maybe there's a ditch bottom width, maybe there's a V ditch, and then you've got a slope intercept to back up. Maybe you introduce, recoverable slope in addition to having a ditch. Maybe you've got a ditch and then you've got a berm. Maybe you've got okay. So these are all the different possible scenarios that we run into with daylighting, and you can run into that on any given project. Well, the way we addressed it is we built a subassembly that can handle all of that logic. Okay, it is a big subassembly. It's not fun to go in and edit, but it is one solution to get you through all of those different possible scenarios. And like I said, you could have any of those scenarios, multiples of them on the same project, and they have nothing to do with your pavement structure. They have no relationship to your proposed roadway. But you got to have them. So we built a single subassembly that can manage all of that. We call it daylight profile control. I'll get into the profile control in just a little bit here. So, okay, so now we've got something that can do all of these things, but we still have the problem that we can't target slopes, widths, and heights. Okay, you can build a subassembly that can target those things. And so what we've done is we built what we call control profiles. So they're profile objects that hang off of an alignment. They have a station value and they have a value, but it's not, it's relative. It's not absolute. So say you wanted to have a slope that was a 3-to-1, that profile would have a start and end value of 0.333. Okay, 1/3 in decimals. If you wanted it to be 4-to-1, it would be 0.25. Okay, so that turns this profile into something that you can manage slopes, widths, and heights with. And in 2016, we added that functionality to all of our sub-assemblies that we could find a reason to put it on. Okay. Another problem with profiles is that to create a profile, you need to create it in a profile view. Okay, you can't just type it somewhere. And these are not visual things. You know, this is basically a XY combination of values. And that was a real pain in the butt. So we built a tool to create control profiles without profile views. And yeah, we added the ability to create, edit, and delete them right there. So you end up with a profile and just a tabular view. Okay, you've got stations and you've got values, and you can edit it right there. Lots of slopes, all those different links, possibilities, means lots of profiles. So we added the ability to standardize and automatically create these control profiles into the control profile editor. Because, like I said, if you keep your daylight variables named the same, I don't care if I've got 1 lane, 2 lane, 8 lanes. I've got my daylight left is my daylight left. So those control profiles can stay the same for every baseline. Build the left and right for every baseline that you have, and you're ready to edit your side slopes. Now, targeting is really awesome for Civil 3D. It's not really easy and awesome for the end user because there's a lot of clicks. There's a ton of clicks. So what we did when we saw all of these control profiles we edited, we said, maybe we can standardize and automate that. That's exactly what we did. So we have input CSV files that give you a combination of a subassembly name and parameter, and give it a wildcard, go get that control profile to set this target to. So we've automated all those clicks. Too much free time. I have not run into that problem yet. If anybody has, let me know. I want your job too. Okay. How in the world does all this work? I am just about to show you. I have to get to work here. So I'm going to get into a corridor file. Not much of a corridor, but I'm going to give you the lay of the land here. So we've got this alignment. This is Highway 25, okay? This is our limits of our existing ground, so I've turned the triangles off just for visibility's sake, but we've got existing ground here, and this is a little corridor that I built that I have not done anything to other than I've got my assembly. Okay, so this is my little 2-lane rural with shoulders and daylight profile control running off of it. And I've got an existing alignment and profile here, all right? And I threw on some cross sections just to, rather than bouncing back and forth or being stuck in section editor, I can see these a little easier, okay? But I haven't done anything other than apply them. And what you see in our run here is we got a lot of fill section here. We got a couple of ditches here. This is just run the corridor out of the box. Now we've got a little weirdness happening here. Well, what's happening here, which can be kind of common for daylighting links, is this is just underneath the existing ground. Okay. So the subassembly logic, which is pretty common in daylighting sub, says, oh, I'm underground. I must have to go I must go up to go find the ground. Well, in ours, our first thing that we do is we don't really have cut links per se. We have what we call a ditch section. So we're always going down and cutting a ditch, and then we're going back up. And what's happening out here is we went and built our ditch, but it went up and it couldn't ever find existing. So then it bermed off and came back down and found ground. But obviously that's not what we want. So, but you can imagine, I'm sure for those of you who have done plenty of projects before, you can run into scenarios where you need to adjust the slope, you need to change from fill to cut, or fill the ditch to fill. Sometimes you might have a break point right here, like you say, okay, I've got my clear zone out at 42 feet, and technically that's right, But this is like a 3-foot link. I'm not going to have construction build that. I want to flatten this out to the same slope as my recoverable for constructability, because it's, it's going to kick out my slope intercept like maybe a half a foot here. I don't care about that. So right off the get-go, even with just this tiny little segment of corridor, I've got tons of edits that I'm going to have to do, and I've only got like 16 sections on here. So I'm going to go through and step through those solutions and show you how it works for this workflow and how fast we can get to cross section. I'm going to do a little time check here and say, okay, we're going to begin. So I've got a alignment right here, and I've got for profiles a 25 exist and a 25 proposed. Okay. First thing I said we needed to do was, we already got the subassembly applied. We've got to add control profiles. We've got to target them. Okay, let's go do that. So this is my slope control editor. It's under the Wiz.Design tab, under the design panel, profile drop down, control profile editor. All right, so for Highway 25, I want to use Wiz.Default and create multiple control profiles, excuse me, create. Chunk. Give it a little time to think. Boom. Okay, so it just finished. So what I've got now is a bunch of control profiles with some abbreviations in them. I'm just going to kind of run through, but as you can see, I've got left and right values here. So some of these are, berm slope, berm height, berm width, ditch for slope width, final slope, intercept, number of intercepts, recoverable for slope, shoulder for slope, okay? So these are all parameter buckets that have values in them. If I go to slope control profile editor, I'm going to pick some easy ones here and go check out my left recoverable for slope. Looks like it's a 4-to-1. I can live with that. And I'm going to check my final slope here. So if I've got a left final slope, if I can click today. Oh my goodness, stop this. I don't know what's going on. I'm going to refresh all. Maybe that'll help. There we go. It's a 3-to-1. Now there's input CSVs for this, and you can change them if you want to, or I can just go here and change. But this is turning these target parameters into input parameters. It's like the default is this, and if you don't change it, great. Okay, so I've got all those control profiles. I'm going to go into my corridor properties here somehow. Corridors. Here's my corridor. I swear my mouse is just knows I'm trying to do a recording today. If I go into the properties and I check out my targeting, which is where a lot of people spend a lot of time, you can see I've got a ton of daylight profile control left and right values. Okay, so what I'm going to do is connect up. I'm going to target all those control profiles to these values here. Okay, but I'm not going to do the click because that takes a lot of time. So I'm just going to cancel out of here. I swear this mouse is going to drive me. All right, so we're going to go again to the Wiz.Design tab, design panel, corridor, assign corridor targets. Okay, so I've got my corridor picked, got my baseline, I've got my region. I'm going to go assign, and I'm going to, I happen to know where this is because I deal with this all the time, but if I go to Wiz.standard C3D 2020, which is the version I happen to be in, components assemblies, We've got a bunch of corridor target assigns in here, and we've provided these for a number of our standard assemblies. I'm just going to right click one of these to show you what's going on with these guys. We've got a whole topic on this so that you can get into it if you really want to, but basically what we've got here is a little table that does, so we've got your subassembly, you've got your target parameter, and then the object name ends up being wildcarded because we always start our edge lines with highway, side, and feature. So you've got to specify side and feature, but you got to wildcard the baseline so that, if you've got, always every project's got a different number on it, or if you got a project with multiple highways, you got an intersection, whatever it is, you need to wildcard the beginning and then you need to wildcard the end so that if there's multiple targets, it can find those. But as you can see, here's all those control profiles wildcarded out. Okay, so I'm gonna not save that, close it so that it doesn't blow up on me. I'm gonna give it the full section corridor target assign. And I'm going to throw on rebuild corridor in there to boot. If you were building this from your own custom assemblies, you could do an export. It'll generate as much of that table as it can. You go through wildcard it and you can plug it back in wherever you want on different corridors, different regions, and get the same functionality. I'm going to click OK here. Modeling corridor, ka-chunk, ka-chunk, chunk, process complete, close that. I'm going to go back into my corridor and check my targeting. Now look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm guessing I got about 22 different target parameters targeted here. And even with all my yakking, it took about 5 minutes. So that's awesome. Okay. Now these sections look the same because I really didn't change anything about the values. They're still the regular values, the input parameters I basically mimicked on the target parameters. But now I've got full control. So all that setup was really to get to a point where I can start editing these cross-section side slopes as much as I want to. All right, so let's pick a nice, easy edit to start off with. I'm going to scroll over and take a look at... Okay, so this is a pretty good one. So let's say this, for some reason, the station 400, I want to change this 4 to 1 to 3 to 1, okay? I know from the subassembly logic that this is a recovery zone slope because I've got a distance out where I'm braking to a non-recoverable. So what I want to look for is my right side recoverable slope at 400. So I'm going to go into my slope control editor here, and so I want the right side recoverable slope right here, and it says that's a 4 to 1. Okay, so what I'm going to do is I'm going to bring that default value, that 0.25, to either side of station 400 and then change station 400. That'll keep all the rest of my station values intact and just change this one and turn it into a linear transition between those. So I'm going to throw in a station 399.75, and that's going to be 0.25. Add it to the table, and do the same with station 425, add it to the table, and then here's my edit here. So this is my 3 to 1 only at station 400. Okay, so I'm leaving all the other recoverable force slopes the same. I'm changing this one force slope. I'm going to update it, update the profile from the table. And I'm not sure why, but these edits don't force rebuilds, which kind of works out for my training here. But let me just check. Yeah, this is set to rebuild automatic. I'm going to rebuild. I'm not even looking at the corridor. I'm going to change it, and it's going to turn into a 3-to-1 for me. Easy peasy, okay? And I've got a nice, handy little documentation. I know right exactly where to find it to see what edits I've made there. Let's try another one. So let's go to 399.75. So where did you go? There, 398, 399.75. So this is a 4-to-1. Let's make this a 6-to-1 and see where it hits. So I know I've got recoverable force slope. This is going to be on the left side. So I'm going to open my slope control editor and go to the 29 left, recoverable force slope. And I'm at station 399.75. So 400 is going to be 4-to-1. 399.50 is also going to be a 4-to-1. And then 399.75 I said 6-to-1, so that's a 0.167. Add it to the table, update the profile, let that thing auto hide, rebuild my corridor, and I've got a 6-to-1. The most important thing, and like I said, you can do this with parameter overrides about, well, close to this easy, but it's not going to scale, and it's going to kill you if you try and do a ton of these. I can do these 2 edits on these 2 objects for miles and miles and miles, and my file size is going to stay nice and tight. My corridor is going to rebuild fast, and I can get my work done. Now, one of the things that's very common with most daylight subs is that they're only dealing with that last link, and they aren't dealing with potential ditches along the way. And one of the things that happens a lot of times is the closer that your subgrade shoulder point is to existing ground, the less often that the default logic of if I'm above ground, go down, if I'm below ground, goes up, works. What we decided is that our users need control over that. They've got to be able to say, I want this to make it, this section to be a ditch, I want this section to be a fill, wherever it might be. So one of the things that we added to this subassembly, we call it a ditch fill switch. So if the value of the switch is 1, it's running on automatic. So it works just like most daylighting subs where it's going to make a ditch. If it's below ground, it's going to make a fill section if it's above ground. If the end user enters in a value that's below 1 for that target parameter, it's going to force a ditch, no matter what. And likewise, for if they enter in a value above 1, it's going to force a fill. So that the computer can't look at the sections like a designer can and say, well, obviously I want a downlink right there. And that's how people want to be able to work. So this switch lets them control that on their own. So let me show you. I'm going to start with a force of a fill, and we're going to go to station 450. 450, and we're going to go on the left side. So let's say that we want this to be forcing to be a fill. So we are at 450. I'm going to go back into my slope control editor and go left side DFS. That's our ditch fill switch. So I'm at what's okay. So I'm going to bring automatic up to station 400. 400, 1, 2. And as I said, a 1 is automatic. So I'm going to add that to the table. And then, oh no, that should have been 425. I'll fix it. So 475 is also a 1. I'm going to edit my 400 to be 425. Maybe. There we go. 25. And then I got to add 450 I'm going to force a fill. So this has to be greater than 1. I like doing 1.5 and 0.5 because if you ever did want to do like a profile view, keeps the values kind of tight. So I'm going to add that to the table. So I've got a force fill, update it, rebuild the corridor, and close my panorama, and whack-a-doodle. This I actually expected because it is a fill slope and it's doing exactly what the logic is. It's creating a 4-to-1 slope. However, that 4-to-1 slope is not intercepting existing ground. So let's flatten that thing out. Maybe a 6-to-1 will work. So let's go and make that edit. We'll go to our left side recoverable force slope, and we're at station 450. So we want 450 to be a 0.167 decimal version of 6-to-1. Add that to the table, and 425 is going to be a 0.25, and 475, oh my goodness, try that again, 475 is going to be a 0.25. So there is my 6-to-1 and bracketing it with the default value on either side. Update it, rebuild it. You don't have to do these rebuilds. I'm just showing it, doing it this way so that it updates and you can see what I'm working with. Okay, so there we go. So we went from a ditch section to a fill section and doing exactly what we want. We've got control over it. Let's force a ditch because that last one was so fun. So let's go to 398.75. 399.75. I'm usually not work like this way. I like really working in the section editor for live. This is really just for visualization for you folks. So 398.75 on the left. I'm going to force a ditch on this side. So 398.75. Slope control editor, left side ditch fill switch, and we need to do 398. Oh my goodness. It's that auto hide's killing me. Try that again. 398.50 is an auto, so that's a 1. And 399.00 is a 1. And then 398.75. This is going to be force a ditch, so it's going to be less than 1. So I'm going to give it a 0.5. Add that to the table. Let that auto hide. Did I? I don't think I updated it. I don't know if I have to do the updates all the time. I'm a little OCD about that. Sorry. And let's rebuild that corridor and see if it works. Boom. Ditch. Okay. Even though we're landing the subgrade shoulder point above existing ground, we can force a ditch. And it's got all the controls to be able to do drive your ditch elevation to custom levels. You can do a flat bottom ditch. There's a whole topic linked in the notes on a deep dive on getting into all the nitty-gritty. But what I want to show you is being able to do this. I've done all these edits. I've been able to target them directly. I haven't added any assemblies. I haven't done any conditionals, anything like that. All I've done is create objects to directly target the sub and keep moving forward with my work. So I'm just going to cover some of the highlights of our daylight profile controlled. I'm not going to get into showing you every single one of them. We've got a lot of videos, as you can see here, with how they work. I did want to kind of cover, but I like to talk about this in the sense that It can do one link down, it can do two links down, it can do a ditch, and it can have a flat bottom or no flat bottom and link back up. It can even go all the way down to a single link that can either be vertical up, vertical down, or horizontal. Vertical up and vertical down is kind of interesting because you can turn a daylight sub that is usually doing all kinds of stuff to it, and you can basically zero it out. You can turn it into a teeny tiny up or down, just intercept and give me a point there if you want to. So it can virtually disappear as long as the existing ground is pretty close to what you're doing. So there's a lot of logic in this, and I'm not saying it doesn't take some work and effort to learn and get used to it. But the reason why you do that is this, and keeping the edits for your corridors and your regions down to a manageable section, because it's not like there's nothing to do over in Civil 3D if you don't do it this way. If you don't do it this way, you get into managing all kinds of assemblies, all kinds of regions, changing the region limits depending on what's going on, and all of that melts away if you've got a subassembly that can manage all those different links, that you can target those links, that you can control the ditch or fill logic on your own, and get the slopes to do what you want to do. And like I said, any job that's got cross sections, if you've got daylight left and or daylight right, this is going to work for you. So whether it's like this, a little 2-lane, whether it's a big mega project, whether it's all the legs of a 5-leg roundabout, daylighting is there if you've got cross sections. And that's why we went through the effort to have a solution that is singular, powerful, will work on all possible scenarios. Obviously, it's not going to work in, the place where this particular sub doesn't work is in urban, because you've got outside in design, and your variability is still there, but you're talking about maybe one link past a sidewalk, or maybe it's truly concrete to concrete. We've still got control profile controls for lane and sidewalk subs there. So you can take those same concepts, because you still, even in urban, you've got existing ground that you got to hit. So that is what I had to show you today. And again, I can't stress enough that, this could go for miles. I could have 200 sheets of cross sections, and I can keep doing those edits all day long. And I've got little profiles that tell me exactly what the edits are. So with that, I'm going to wrap this up. I hope you learned something, saw something you hadn't seen before, and had a little bit of fun while doing it.